Hello again. Welcome back to the Critical Angle of Fact YouTube channel. My name is William Lowe, and I thought we would talk today about some things that have been on my mind for a long time, including airplanes and the 737 MAX and some of the other models and the airworthiness directives that were put out after the first accident for the Lion Air 737 MAX. As you can see in the background, airplanes are a balancing act, and this one here, somebody's put the cargo in a little too soon or something, and I think one of these guys over here is having a bad day. So even on the ground, you need to be aware of the CG. And most subsonic airplanes are basically the same. So wings and a fuselage, tube and wing, it's called, in that sense, the B-47 really, plus a tail at the back. The wing needs enough air molecules going fast enough over it or it won't fly. This is called stalled. Jet airplanes have swept wings, and this is about a 35-degree angle. Thank you, Germany. And they have a wide airspeed, altitude, attitude, and center of gravity range. So the design needs to be able to handle all of that safely with no surprises. And this is helped by having a horizontal stabilizer in the back. So way in the back of the airplane. It's another wing, really. It's upside down, though. So it's mounted upside down, so the curved part is on the bottom. But this allows the airplane to be trimmed for its current speed. You can move the stabilizer, and this is called trimming it. And this is so it goes smoothly through the air and doesn't put the nose up too much, which would cause you to stall, or put it down, which would cause you to get too fast or hit the ground. How airplanes work, they're all pretty much the same. And this symbol here is the center of gravity. That's where the weight vector is acting. The center of lift is a little bit in back of there. So this causes a nose down pitch moment. And this has to be balanced at different airspeeds, altitudes, air densities, CGs, angles of attack, flap, slats, landing gear settings, and bank angle. So it's a big deal. The stabilizer, like I said, is an upside down wing. And so its lift vector is pointing down. And this adds about 5% to the weight of the airplane for 40 years if you convert it to a freighter. It's a source of inefficiency in this way, but it's also a source of stability because this imbalance and the stabilizer kind of keeps the airplane in a normal attitude. But this means the wing's lift vector must be greater than or equal to the sum of these two. Otherwise, you're going to start going down. This means in turns too. So if you bank the airplane, the lift vector, this arrow, is tilted over to the side. So the vertical component gets smaller. To stay at the same altitude then, like in a holding pattern, you need to pull the stick back in your bank, in your turn. That increases the angle of attack, increases lift, puts G on the airplane, so increases weight too. And all of this will result in a reduction of your margin to stalling, so the stall margin. I've included this so you can see what we're talking about with angle of attack. So in this wing up here, the relative wind, which is what these little vector lines and curves are. The relative wind is hitting directly into the front of the wing and going smoothly over the wing. And this curve causes this air to move faster, and that makes it be a lower pressure on top of the wing, which creates lift. And also this section underneath deflects air downward, and that creates lift too. This over here is an angle of attack indicator. In this case, everybody's happy. as we go down, now the nose of the airplane has been, the pitch angle has been increased. So the angle of attack is increased too. And that means this, actually the chord line through the wing here is what that line is. Down here, we have raised the nose too far, and we've messed up the airflow across the top of the wing. So now we're at or above the critical angle of attack, and this thing is flashing and making a sound for you, trying to help you out. Military airplanes have, some of them have 3 of these. In the F-18, it's right on the kind of the dashboard right in front of you. So it's so important. I'm amazed still that some commercial airliners do not have such things. So the 737 MAX mess has been beaten up pretty bad already, so I'm not going to go into all the details. I'll put some links in the description if you want to read about it. There's a JATR report that's very good, and I'll put a link in there so you can see all the details. But basically, here's a fancier picture of the angle of attack. So here's the chord line I was talking about. Here's the relative wind, center of pressure, center of lift really, which includes the drag, and this is the resulting force of lift. In the MAX, they figured out that in certain regimes of flight, they were getting close to stalling. Too close, really. So the stall margin was too small. And this happened with the flaps up. So that means the stall speed is higher. When you put the flaps down, it increases the chord of the wing, actually. It makes the chord line be more steep going down, and increases the angle of attack, and you get more lift. And so in this case, in the Maneuvering Characteristics Augmentation System, MCAS, was allowed to move the stabilizer, but it was only based on one angle of attack sensor input, even though they had 2. They have flight control computers, 2 of them. Each one is connected to an angle of attack sensor outside on that side of the airplane. And they somehow just chose to use one. So a single point of failure is not great for flying airplanes safely. After some testing, they also figured out that they needed to make the amount of activation greater. So they went from 0.6 degrees to 2.7 degrees per activation. So depending on where the stabilizer was in the beginning, this is possibly full nose down trim already after 2 activations. To avoid simulator time and some financial penalties in certain contracts for the sales of the MAX, the airlines, the pilots, and the FAA inspectors were not told about MCAS, and the software did not even include something that, if you know anything about Excel really, you would be familiar with. So I'm a software developer, but that's not necessary for this. If your airspeed is greater than 290 or some number, or your altitude is less than 10,000 feet, or some other number that you want to set in there, or this thing is activated already recently, then stop it. This seems like the sort of thing that people may have assumed was in there and didn't actually check it to make sure it was. It's hard to say for me, but pretty amazing, because this is what they've done in the update in the software. They've really tightened that up, and it just begs the question, how come that was not done before? So I say risky stabilizer code. That's true, because in the transition between aircraft types, when you are going to go, say, from the 737-300 to the 800, or from the 800 to the MAX, they do what's called differences training. And this is what Boeing was trying to avoid anyway, to have that deal with simulators. But from a pilot's point of view, there were some big differences that were not mentioned if you're used to the Dash 300 or 800 and say you've got your 15,000 hours in them, and then you start to fly the MAX, you would find that the MAX did not shut off a software module called speed trim, which is where MCAS lives. It's where they put MCAS into the code. And if you hit the electric trim button on the yoke, or if you pulled hard enough on the control column, the speed trim system would stop. In the MAX, it did not stop. Also, before, the switches on the center pedestal that Boeing pointed out in the AD to turn both of them to cut out to stop the electric motor. So in the previous airplanes, one switch shut off the computer inputs to the speed trim, and the second switch shut off the electric power. On the MAX, both switches shut off the electric trim motor, so that's another big difference. These differences in the stick shaker, which is a frightening thing if you're not used to that. It shakes the stick and makes a racket too. It's amazing. You can see videos on YouTube about that too. But this might have caused the Ethiopian pilots to be startled, and the captain was actually doing a good job with the electric trim in fighting against MCAS. So he did pretty well, while the co-pilot looked through the manual. So the airplane flight manual, a pilot's operating handbook, for something that was not mentioned in there. So he eventually said he didn't find it, and the captain said for him to please fly the airplane, and the captain would look in the book. So the co-pilot did not do as well as the captain, and the MCAS eventually got the nose down. These guys, have been blamed in a big way, singled out even. But they were not perfect. They left the power at 94%, which is way too much. And they eventually got to, because of also the nose down trim, they eventually reached 375 knots. Also in low altitude, the air is denser too, so the forces on the airplane were even greater. And so they have done some simulator testing, and that was the source is Flight Global. I'll put a link down below. But they figured out that starting with the trim setting that these guys had in the beginning, if you got to 220 knots only, that would jam the stabilizer, because the elevator is a little flap on the back. If we say this is the stabilizer here, the elevator is back here, and the stabilizer is the whole thing, so it's way bigger and has a lot more force. But if you get the nose trimmed down, you would pull back, everybody would pull back on the control column, and that's connected to the elevator. So that means the elevator would be competing against the situation, against the stabilizer position too. And that would put big aerodynamic loads, especially at such a high speed and low altitude, onto the jack screw that moves the stabilizer. So it would get jammed in a big way. It's also clear that in the manual trimming, in this turning of this wheel by your leg on the center pedestal, it takes 15 rotations of that wheel to move the stabilizer 1 degree. So these guys couldn't move it at all. They turned back on the electric trim, and that reactivated MCAS, and it still was out of whack and still put the nose down and kept right on doing that. And they eventually crashed, as everybody knows. In the training, for the 737-200. So back in the day, in the manual, it used to have a section about roller coaster maneuver. Because if the stab gets out of trim and it becomes jammed, you need to actually put the nose down with the control column to relieve this load on it. Manually trim it if you can, and then you pull up again. So it's jammed now. Then you put the nose down again. Once you gain some altitude, you put the nose down again, just like you're on a roller coaster, up and down. And this was taken out of the manual after the 200. And this is also not mentioned in the Airworthiness Directive that came out after the first accident in 2018. This is it. I've excerpted some sections out of it. I'll put a link also down below. You can read the whole thing if you want to. They mention here, for the first time, FCC command of pitch trim. They say to improve longitudinal handling characteristics. And that was always the idea from Boeing, that it was something to do with control feel. And a lot of people came out and agreed with that, which was a surprise at the time. But then after the JATR report came out, that got a lot quieter. In the event of a bad input, the pitch trim system can trim the nose down in increments lasting up to 10 seconds. Higher control forces may be needed to overcome any stabilizer nose down trim already applied. They found in the testing that if both pilots pulled back on their yokes on the control column, that they could save the day a little bit, but one pilot was not able to do that using only the elevator, so the stabilizer won. So it seems like this would have been a good place to mention some of these differences between the prior versions of 737 and the MAX. Having the speed trim system not shut off would really be a strange thing if you're, like I said, if you had your 15,000 hours of having it different. Also, this control column cut out. If you pulled back hard enough, it would stop the speed trim too. In this case, the speed trim kept right on going because they needed MCAS to keep active too. They've tried to blame all this on Mark Fortner. His emails and those of the other people are beyond ridicule, really. To in a safety-related company, to have done such things is just bottomless. I can't believe it. But it wasn't just him, clearly. And for an AD to come out after that first accident and not mention clear differences between the types of airplanes that these pilots would have been entrusted with. It used to be the FAA's job to avoid this sort of thing. So in this case, hopefully this is so bad, this is the sort of thing that will lead to real change. It already has done. The Boeing has already updated the software and made all these fixes, and the 737 MAX is flying again already. I don't mean to say it's a bad airplane. I've seen people still saying that in the press and various places, but that is silly. It's probably the safest airplane ever now. It has been tested through and through, and they did find some more things that they've updated and fixed too. So here is the cockpit of the MAX. It's gorgeous. And very big displays here too. It's amazing. On the captain's yoke, the trim button is on the left. On the co-pilot's yoke, it's on the right side. And this wheel here and this wheel here, these are the manual trim wheels. They have a white stripe on there, you just can't see it in here. But it's got a little handle that pops out, and you can rotate that wheel a lot of times if it'll still move. These switches right here are the switches that they wanted to be set to cut out. But Boeing got this amazingly wrong. Cool, they got it right for my dad, who flew 21 years in various Boeing airplanes. And amazingly, ventral strakes, or ventral fin is another word for it, may have avoided the whole thing. And what is that? Here's a bunch of them. These fins on the back of these airplanes, the Learjets, all the way in the back of the airplane. This is the Italian trainer that I got to fly in Orlando in the simulator. It's got ventral strakes too. This is an F-14, which is a big girl. So this thing may be 10 feet long. Over here, this is an F-8 Crusader designed in the 50s, and also a big girl, and this may be 10 feet long as well. This airplane is based on a Global 7000. This is a military version, also maybe a communications node, but it could be airborne early warning too. But the ventral strakes are in the back, and these two airplanes have a high tail, so they are in danger of what's called getting into a deep stall, because if the relative wind is coming at an angle like this, the big wing is going to blank out the horizontal stabilizer, and you'll have limited to no control authority to put the nose down. So they really don't want that. That's why they have these strakes on the airplane. Also, these two airplanes have a stick pusher, so it kind of behaved like MCAS did before they've updated it, putting the nose down for you to avoid having a bad day. This airplane in the middle is amazingly based on a Boeing 737-700ER, so the Boeing business jet version. This is airborne early warning airplane. It's called the wedge tail. There's the antenna up there. And so Boeing knew about this. People tried to get them during the MAX program. People said they should try the ventral strake, but I think they, again, were trying to not attract the wrong kind of attention from the FAA and trying to avoid the simulator training. So they chose to go for a software change. Some people call it a software band-aid. Here she is. This is an Australian one, but you can see the antenna here has about a 7-degree nose down pitch of its own. And here's a Turkish one. It's kind of a better view of it. But I bet that antenna, because it's behind the center of gravity and it also influences the airflow, I bet it causes a nose pitch up too. So that's why they've put these on the airplane. This is actually the 777X's first landing in Frankfurt just a couple of weeks ago. So this is a Dash 9 prototype airplane. And the point of the video today has not been to blame anybody or single anybody out, but to focus on the process, which I don't think it's broken, but it could be improved upon. So if there are differences, they need to be included in the differences training, and the airworthiness directive needs to reflect that too. If there has to be an interim one, fine. Because we're not through certifying airplanes like this one. Look at the wingtips folded up. And this is a 737 MAX A.D, so a Dash 200. So it has the extra exit door in the back of the wing to evacuate people more quickly. And the MAX is a great airplane. Like I said, it's the most tested airplane ever now. And the 737 entered service in 1968 in the beginning, so I think they have it figured out by now. Hope the video was helpful, and you can click on like or subscribe to the channel, and we'll be doing some more of these. So take care. Be careful out there.